Hey everybody, this is Larry. This is me trying to do an extra algo problem. So let's give it a spin. Let's give it a YOLO, and hopefully it's not too hard. I keep saying that, but one of these days we're going to run out of not hard problems, I guess. Anyway, today's problem is 25.48, maximum price to fill a bag. And it's a premium problem, and one problem that doesn't have more downvotes than upvotes, which we've seen a lot lately, so we'll see. So you're given a 2D array items where items of I is you're going to price weight. Okay, your positive integer capacity, is this going to be like what you call it? Knapsack. Let's see. You have some capacity. You have each item can be divided into two items with ratio part one and part two. Okay, the weight of the first item is okay. All right. I mean, so it's just this is a really weird way of saying that. It's a weird way of saying that you could just divide them and it'll be proportionate. I don't. Yeah. I mean that's fine. Okay, return the maximum total price to fill capacity given items. Maximum total price. Okay. Well, I mean this is just greedy, because you yeah, this is just greedy. Basically, the idea is that I mean this is just literature. Like as some of y'all might know, I watch a lot of chess, right? Lately anyway. And if you watch chess, let me know in the comments and how you if you've been watching Chessabos and all these other contests. And the candidates are coming up. That's exciting. I mean, I guess it's not coming up that soon, but I'm excited about the candidates. But in any case, sorry. But what in chess they would just call it. This is like a book, right? Like yeah, this is just a literature. This is problem. This is like, fractional. And if you haven't seen it before, it can be hard. I don't know how to kind of go into it if you haven't seen it before. But it is greedy. But it's greedy based off, and this is just something that it is fractional knapsack, and it's just known to be greedy. I mean, I think there's certainly proofs, but I think like for me, it just kind of makes sense because you can break it up. And that's basically the idea. That's what we're going to do. So basically, the first thing that we're going to do is we'll sort items. And what we want to sort is actually by the price to weight ratio, right? So that's just, let's go this. Is X a good item name? No. Yeah, okay, fine. Right, so price by weight, right? And here we actually want the most expensive per weight, so we want to reverse it in this case, right? True. And then that's pretty much it, right? So while so then for I in range of n, or maybe even just like for what's it, price rate in items, right? And then total is equal to 0.0, right? Yeah. And then here, if so, basically we can use is going to be equal to min of W and capacity, because whatever's less we can take from it, right? The weight, right? So then, and this times P is going to be the price, because this is just going to be some ratio of the weight, right? Yeah. So then we add that to the price, and then capacity we subtract from use, and that's pretty much it. And then we just pretty straightforward, unless I'm really wrong and I'm thinking of a different problem, or I'm just misreading and misunderstanding this problem altogether. I thought it's supposed to max. Am I confusing this? It's possible that I'm also confusing it, right? How did I get 90? So this is the way that I'm doing it is definitely not right. Or maybe there's some price. Wait. So okay. It should be easy to debug though. I think the idea should be right, so I don't think I'm wrong here. Okay, so then you have 51, and okay, that looks right. So then what am I doing here? Okay, so yeah, we use 1, and it costs 50. So then now we use 4. Oh, this is just, the math is wrong. It's not, oh, P is not per unit. Sorry, that's why. Usually it is per unit, maybe not. But yeah, it's gonna be, so you want to normalize it per unit. It's gonna be this times this. Sorry, I kind of, in my head I thought it was unit for some reason. Oh, and in this case, I actually just forgot a case, which is if capacity is greater than 0, then we return -1. But it may be a little bit tricky because of, I don't know. We'll see how that goes. Why that took so long? We'll just YOLO submit. Using it like this is a little bit sketchy. It may give us a little bit wrong answer, but thankfully there's nothing like that. So yeah, this is going to be n log n due to the sorting, and everything is pretty straightforward. Fractional knapsack. If you really want to read up on it, then you can read up fractional knapsack. I think that's what it's called. This is of course as opposed to the more commonly known 0-1 knapsack, right? Where you can, it's binary. You take one or none, or I guess variations on that, but still. Yeah. That's all I have for this one. Let me know what you think. Pretty quick day. Pretty on an interview front, I think this is a little bit too easy to be on an interview. I mean, I don't even know if it's easy per se if you haven't like done it before, but it is literature, right? So I guess in that sense, I don't know. I could see that if you have like multiple questions on an interview, this could be one of them, but otherwise I'm not sure. Like it's not that interesting. I mean, I would say that it is nice to know, and of course greedy prompts are really hard, as you know that I would say, and I am really bad at them. So maybe get as much practice as you can, and this could be one of those practice. Yeah, that's all I have for today. That's all I have for this one. Let me know what you think, and yeah, stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye bye.